Hey everybody, welcome to episode 8. Episode 7A and B were the troubleshooting videos, but we're back in a good spot here, and I want to explain to you what happened and what we're doing differently now. So, first part is when the transformer I'm using in here, when I first got it, all the wires were disintegrated, so I had to rewire it. Now I thought I did a good job of ohming out the high power side and finding the center tap, but apparently when I wired it, I used the wrong wire. So when I connected it to the rectifier tube, I actually had, one side, which was about 260 volts going to pin 6, and the other side was about 700 volts going to pin 4. Now fortunately, when I was testing this thing, I always had a meter on it, and I never ever let it go above 400 volts. So basically all the caps that I have in here didn't get ruined because I didn't exceed the 400 volts. Now I've got a 500 volt cap, and those are 450, so I didn't do any damage. So essentially what I did is I corrected the transformer windings, and that was good. And then I was able to get the transmitter up and running. But the problem I had is that I was getting about 340 volts of B+, right? And if you look on the schematic here, you'll see that it's calling for 300 volts DC, and I was getting 340. And this output tube, this 6L6G, really can't handle that. It's really not rated for that on the plate. It's rated for 300 volts. John from Arkansas was very clear to point that out to me yesterday, that that's a problem, and he's right. So all I'm really doing here is I'm adding a resistor right here between this connection. So I've got a 2K here, and I'm starting off with a 2K here. And just to show you illustratively, here's the second 2K resistor that I'm going to put in with gator wires that will connect up through here. Okay? So when I turn that on, I should get somewhere near 300 volts, I'm hoping. We'll find out. So let's turn that on. Let's check that first and see what we get. So we're going to turn on power. Let's see what we get here. So we're going up to 450, and then we should bring that back down. There we go. So we're about 295, somewhere in that area. Okay, good. So what we're going to do now is we're going to turn on this AM radio here. I do have my MP3 player connected. Let's see what we got. Lower this music. So I bought a cheap Chinese frequency counter, and I have it connected directly to the tuning cap. And you'll see that I'm right at about 655. Alright, so let's see how that works. Now this radio is crappy. It's hard to see what that says in there. Let's see if I can get it. You can't see that. So I'm going to put the radio somewhere in the 900 range. Now let's flip this up and see what happens. There it is. So I know that it's 96. That's where I'm tuned. So I like that. That works out good. So this unit is powered by a 9-volt battery. So I can easily put a 9-volt power supply in there and connect it. So I'm definitely going to add this to the design, and I can actually see what frequency I'm turned to. So if any of you build this and you want to add that feature, real simple. You're just going to connect one wire on either side of the connection that goes to the tuning cap. Okay? Here's the plan going forward. Plan going forward is I have to mount this box on the top, run the wires through, start to connect everything. I have to build my my speaker connection, or my input I should say. I have it right here gator wired. And we're gonna mount that inside, and then we're gonna come back and we're gonna so basically, what you'll see here is we just need to clean up for good here underneath. I need to mount everything, and I think this frequency counter thing is really cool. So at least it'll give you an idea where you are. Now if your station drifts, you just kind of tune this right here. Just dial it right in. holding steady at 297 volts. That's on high power. Low power, we're at 260. I probably could get away with a 1K resistor here, and this way my low power would be 300. But then the high power would go up, and it's really not good for that output tube. So I think I'm going to keep it where it is. So that's the update for today. Mystery solved. Now we're going to mount these boxes, which I've stained, and get all that stuff done. And I'm going to figure out where I'm going to put this thing, and I've got to get this meter. Actually, let me connect the meter, and I'll show you what that looks like. Be right back. Okay, as you can see, I have the meter connected. It's milliamps, DC milliamps. And I'm currently set for low power, and I'm currently getting about 0.25 or 6. And let's switch this to high power. I'll pull back a little bit and let's see what happens to the meter. And I'm currently getting about 0.44 actually. Now what I don't know is what's the right reading. So I guess I should throw a meter on there and see what a true reading is. And that will help me determine which resistor I need to put here. Right now I have a 22K resistor there. That was keeping the needle from spiking out. So we've got our frequency counter, we've got our meter, and we've got our box here. So that's the setup. Anyway, I'm going to end this video here, upload it so you can all see the progress. And we're looking really good. One last voltage I want to check real quick. I'm getting 166, and that is right here on the schematic. And look at that, 167. That's exactly where I have that meter connected right here. So we are dead on the money. 166. At low power, we're dead on the money anyway. So let's go back to high power. And we're back there, and here we drop up a little bit. Anyway, that's the story, folks. Anyway, thank you for all your help with this. I really appreciate it. The next video, you're going to see this thing start to take shape, and it'll be much neater than it is right now. Have a great night.